Imagine you are building a real backend application. Users are signing up, orders are being created, files are being uploaded, payments are being processed. Now here is the question. Who will send the daily reports? Who will clean the expired tokens? Who will retry the failed payments? Who will delete the temporary files? Who will run the database backups every single night? You? I don't think so. This is where cron jobs jump in. In this video, we will talk about what cron jobs are, why are they important, the most common real-world use cases you will see in backend applications. And if you are learning in Java or Spring Boot, this is one of these concepts that looks simple but becomes very important once you start building real applications. So what is a cron job? Cron job is something pretty straightforward. Run this piece of code automatically at a specific time or interval. For example, run every 5 minutes, run every single day, run one day morning. That's basically what happened. Every single duration, it executes some kind of code. Instead of manually clicking a button or running a command, the system does it automatically for you. Cron jobs are used to handle many repeated tasks that need to happen in the background. Here in this example, I have prepared it just for the sake of explanation here. Here we have a payment system and we want to notify the user with their upcoming payments. Because usually when you have like upcoming payment, you get like some kind of notification to tell you, hey, there is upcoming payments that you need to be aware of. So how do we implement this kind of stuff in our application using Spring Boot and Java? I'm going to show you here a really good example for the upcoming payments through this kind of annotation. We have here at scheduled. At scheduled annotation is basically taking a cron expression. This cron expression can be anything of those type because it has some kind of pattern. This is a pattern. We have seconds, minutes, hours, what day of the month, or even the month that you want to look at, or maybe day of the week. So this is basically the pattern that's being used when we're working with the cron jobs. People use it simultaneously as a scheduled jobs. So some people say task, some people job, some people say cron job, some people say scheduled job. So whatever kind of name you use, it is the same. Every single duration of time, you run some kind of a code. So this is why we need the cron expression here. The cron expression, like I have showed you, are some examples you might want to look into. But basically the main point here is to have that scheduled annotation. Here we're defining the annotation to be this value. This is also coming from the application YAML. So in the application YAML, when you go to the cron job here, we're using this pattern here. This means it's gonna be every single day at 9 o'clock. That's basically what we're gonna be doing. And 9 o'clock here, we're talking about 9 a.m., not p.m. Why? Because we're using 24 hours format. We're not using the 12-hour format. So basically 9 here is covering for the 9 a.m. And by the way, in addition to the cron job, you can specify the zone. Like if you're using, for example, Africa, if you have a different time zone rather than Africa, let's say you're United States, it will be in different time zone with different country. So basically this is the zone that you can specify as well. And now every single duration for this cron job, it's gonna be executing this logic. So what happens here? Here we have just a service responsible for execution of our task. So we have a job name and a task that we want to process. What is the task? Is processing upcoming payment. That's basically what we want. We want to remind the users that they have some kind of upcoming payments. I just want to show you what is run job do. Run job is just straightforward. We're just making some kind of validation here, whether we're talking about job name is or as a task have some kind of wrong values. If it bypasses this part, we're going to be saving the cron job execution in our database. And then we want to execute our task, which is a supplier of some number. And in case everything is succeeded, we're just annotated with success. We're setting the total and we're returning the total number of being processed. In case of some kind of exceptions that happen, we're returning 0 with a little bit of logging here. That's basically what cron job does. So what happens here in the processing upcoming reminders? What the cron job usually gets some kind of data from the database, modify it, and do some kind of action with it, process it, and basically the task of the job is done. So this is what usually happens when we're working with cron job. Like this one, we're having that today, and what is the due dates that we want to notify the user before. We have the page number here because you don't really want to get everything at once. You might want to use pagination, and we're going to be using infinite loop here. And we're going to be breaking this loop in case we find no remaining object. So here we're going to find page by page, where we finding by status pending, and the due date is between a specific range, which is today, and the end date, which is basically the upcoming payments. And we're going to be finding with a specific batch. This batch is configurable size, and we have a page number starting with 0. If the page is empty, that's basically mean we don't really have any upcoming payments. So we're breaking this loop. And then we're going to be iterating for every payment we have. We're going to be creating the notification if it doesn't exist. And we're just incrementing that count of the total processed. In case the next page is empty, we're going to be break as well, because it's going to be pointless to iterate for the next page. We're increasing the number of page in order for the second loop, and we're eventually returning the total processed, which was being used in the run job here, which is the total process. So that's basically the idea of cron jobs. That's how cron jobs work. In addition to that, I wanted also to introduce something here. What happens, let's say, if you have two instances running simultaneously? By two instances here, I'm talking about two clones of your application running together, maybe two pods running together, and there is some kind of load balancer that distributes the loads. So what happens if a time happens and both of them are similar? Like they have the same time zones, they have the same time, everything is the same. So when time happens, it's going to be executing this part, which isn't really optimal. Why? Because this means we have two instances doing the same kind of work, and it might cause some kind of conflicts due to some kind of race condition, which isn't really optimal. So what do we do in this problem? We have something called scheduler lock. This comes out from the shed lock dependency. So here we're making, hey, we have some kind of lock which is called this name, upcoming payment reminder job. This is a lock responsible for at least locking the database for this time, 1 minute, until at most this time, which is at most of 15 minutes. We're locking this kind of database as a lock, disallowing any transaction to work. No, it is more of we're locking any other scheduler. We're preventing any other scheduler to be running on the same database as long as we have a log that's happening named as upcoming payment reminder. Just to be clear here, that's basically the table of the shed log. We have name, we have logged until, and logged at, and logged by. So when we have two instances here, the first instance that runs this cron job is going to be inserting in this table, shed log. It's going to be insert the name, which in our case was this upcoming reminder, payment reminder job. It's going to be locking it until the current time in addition to 15 minutes. And it's going to be logged at. That means the time of the moment that the cron job started. That's the logged at, and logged by the instance that is running. So now the first instance have logged or created a record in our shed log table. Now the second instance is going to be trying to insert, or basically the second instance will be trying to run the scheduler again on the same job. So what happens here, it's going to be checking the table, the shed log table. Does there some kind of locking that's happening during the time that I'm going to be starting with? And guess what? We have already inserted one here. So this means we're not going to be starting the second job from the second instance. Why? Because it will find that an existing record already exists. So it will skip the running of that job by the second instance because the job had already been started. This is basically the idea of the shed lock that is being used here. This is also a good point to mention in case you're running in a microservice architecture where you have horizontal scaling. So that's basically the idea. This is also being used in a simple task. If you want also more advanced task, we have some kind of other complex scheduler such as Quartz. This is more advanced scheduler that some people use in order to have more complex tasks. If you would like me to talk about this topic, feel free to comment it down and I will be making a video about it. If you're interested so far, feel free to check out this video or this video. Most probably you're going to enjoy one of them. See you next time.